Okay, so we are on the list this page. In the previous class, we are discussing about the the network was lost due to the internet facility in the previous class. So I'm just repeating once again. We are discussing about the tensor and vectors. What the difference between the tensor and vectors? So if you're talking about the simple scalar quantity and then the vector quantity and then the tensor quantity, what is the tensor? So just to, if you want to differentiate this, I'm just taking the new slides so that you can understand it. So let's say this is a scalar, this is a vector, and this is a tensor. So what is the difference between these three quantities? So this scalar has only the magnitude. However, what is the example of this? The simple example is a time, mass, distance, you know, uh, temperature, right? Entropy. These are the example. Electric potential, population, pressure, and concentration, etc. These are the basic examples. These are the general used terms, generally encountered terminology, which are comes under the category of the scalar quantity. However, in the vector quantity, this quantity has magnitude as well as what? As well as direction. Is the message audible to all of you? Yes or no?
Yes, sir.
Okay.
Yes, sir.
So magnitude and direction. Okay. And also this follow the triangle law of addition, right? Triangle law of addition. Right. So what are the examples? Simple. If the velocity, velocity is simple example. Force, right? Displacement, right? Electric field, right? Intensity, electric field, intensity. Then you talk about the momentum, right? Then momentum and etc. Right? These are the simple example of the vectors. Okay. Now, what is tensor? So when we define tensor, simple tensor are the family. Tensor are the family of geometrical objects. Geometrical objects, right? Objects which either help you to represent the physical quantity, right? So physical quantity. So physical quantity कौन कौन scalar भी physical quantity, vector is also physical quantity, right? So and another quantity also, there's a tensor. तो अभी हम देखेंगे इसको physical quantities or can be used to provide a relationship between scalars, vectors, or other tensors you can say. So what are this? So आपको अभी समझना होगा कि जीरो अगर हम कहते हैं what is the zero other tensor? So what does it mean? Zero order tensor means, sorry, zero order tensor, not zero order tensor. Zero order tensor means this represents only the scalar quantity, right? It only represents the scalar quantity. It means if we are talking about the zero order tensor, it means we have only required, it just requires a number to represent. Okay, इसको हमें क्यों क्या चाहिए? नंबर चाहिए, नंबर रिप्रेजेंटेशन. Scalar means the number representation, nothing else. Okay. And if you're talking about the first order tensor, it means we need two representation. First means this is the example of the vector. You can say in this category the vector can be kept. Okay. So it requires two physical phenomena or information. Okay, two pieces of information, you can say more precisely, two pieces of information. वो कौन कौन से information है? So first one required, let's say, the magnitude, and second one is required direction. So if you are able to represent the information with the help of magnitude and direction of any physical quantity, that comes into the picture of category of vector quantity, right? Another last one is having the you know the second order, you can say second order tensor, and in this category we require, the requirement of this category is क्या क्या चाहिए? We need magnitude, we need two directions. Simple, if there is only one direction, then you can say there is a vector quantity. If it contains only one magnitude, that is a scalar quantity. If we have two directional material है और कोई physical quantity है, and there's also the magnitude, so two directional, or you can say indices, such as the best example is the stress. Okay, stress and strain. So this we will discuss in brief, also in details, how the stress requires two dimensions. Okay, or you can say magnitude. So this is the second order tensor. Okay, so आप इसको जरा stress को और समझते हैं हम लोग more precisely. So for stress, you can say that we need three pieces of information, two direction, and one is the in magnitude, obviously. First one is obviously the magnitude of stress, कितना आपने magnitude है उसका, or it is simply given by, represented by sigma. Okay, for normal, right? For normal, and it is also represented as tau for the shear stress, SHER, shear stress, right? Second, these are both are the magnitude. Second one, where you are going to apply this stress. So the face on which it is going to act. Yes or no? It is going to act. So it is given by first indices in first direction. It is the first. It represents what? First index in subscript. Right? And third one, the direction is another direction. That is the direction in which it is acting. Okay, on which it is acting, on which face is acting, and in which direction it is acting. Okay, it is acting. So it is given by the, you can say, second indices or index in subscript. तो कैसे लिखेंगे इसको जरा देखते हैं. How it is represented? See. How it is represented? Please see. So let's say this is the representation of any stress. So we can write that sigma x. Okay. Then okay, you can write it sigma s and tau sigma y and sigma z, and this is the tau xy, tau xz, tau xy, tau yz, tau xz, and tau yz, right? So this is the representation of the stress. Okay, in which the sigma x, sigma y, sigma z represent the faces, है ना? और आप किस डायरेक्शन में रिप्रेजेंट करें, that is the represented x. So what is this xy represent the, this is the face and this is the direction. Okay, so simple definition of, you can write the tensor, simple definition you can make on basis on this discussion. The precise definition, you can say, the precise definition of the tensor is, it is a set of numbers are written in a square matrix, a square array, or you can say the matrix, we say generally, we say that as a matrix. ये array क्या है आपका? This is the matrix. Suppose if we attach a coordinate system, right, to describe the same set of numbers in that array, then we call the same matrix as a tensor. So it means you have the more than 2 dimension. Okay, more than, अगर आपको 1 dimension से ज्यादा अगर आपको कोई physical quantity का representation है, then only we can represent with the help of matrices. We will see more in the coming example, right? So when such type of problems will occur, you can say the second order tensor, third order tensor, fourth order tensor, and many more, right? Is it okay? Now come to the next. Okay, now come to the next problem part. So this is the simple problems, just to try to solve this one. Okay, and then we will move toward the multiplication today. Okay, so first problem is simple. First problem is here. It is given A matrix is, and the last I will take the attendance once more. 10ax minus 4ay plus 6az, and b is equals to 2x plus ay. So we have to find the component of a along ay. Second problem is we have to calculate 3a minus b, and third problem is you have to calculate a plus 2b. So in order to that, a simple question, simple answer of first question is what is the component of a? Since a is equals to 10ax minus 4ay plus 6az, so it is very simple. What is the component of a along y? So ay is nothing, the ay is the direction, and the associated magnitude is nothing but 4. So you minus 4. So simple, the component of a along ay is minus ay. If the question is asked in this such way, what is the component of z or x? So the component associated with the ax is simple 10 and z with 6. Okay. Second question, 3a minus b, you can calculate. This is a simple magnitude multiplied with the a vector. So you can also write this one. This is one way to write. So what is this? This is simply 10ax minus 4ay plus 6az. 3 into 10ax minus 4ay plus 6az, or you can also write the component here, right? 10 minus 4 plus 6. It is by default, it is known that 10 is with the x, y, and z respectively, right? 10 is for the x, minus 4 is the y, and 6 for the z. Similarly, you can write this one, b vector. So b is represented by the 2x plus ay. So the magnitude of this 2 and 1, and z is here 0. So you can write here. Okay. So simply this is a 30 minus 12 minus 18, and just discuss minus on this. Okay. So my class move. So 28 minus class. 28 minus 13 minus 18, you can, or the final answer you can write at 28 x minus 13 ay plus 18 az. So this one is the 3a minus b vector. Simple. Okay. So how the magnitude be calculated? The magnitude of this one. So magnitude you can calculate simply 28 square minus 13 square plus 18 square. Okay. So this is the magnitude of 3 minus b. Third question is the unit vector. So you can first calculate the a plus 2b vector. Then let's say this is the c vector is equals to a vector plus 2b vector, right? And then what will this? The direction of AC is nothing but the c vector divided by the magnitude of c vector. है ना? तो इस तरीके से आप you can calculate like this one also. So this is the final answer. Is it okay? Now come to the next. Next question is, if point P and Q are located at this place respectively, So the point P is at 0, 2, 4, and the point Q is at the minus 3, minus 1, 5. So calculate the position vector P to Q, distance between P and Q, and vector parallel to PQ with magnitude of 10. So how the position vector P is calculated? Simple. This is the RP. Okay. So RP means 0AX. It represents the position vector RP. 0AX plus 2AY plus 4AZ. Right. So this one is the position vector for the RP. If it will say the position vector of the RQ, similarly you can write minus 3AX plus AY plus 5AZ. Right. So this is for the RQ. Now you have to calculate the distance vector from P to Q. So you have to calculate means distance vector P to Q means RQ minus RP, right? RQ minus RP. So position vector you know RQ, and position vector of the P is known. You just minus, take the minus of this one, and then you calculate the RPQ. Okay. What is the distance between the PQ? So you can calculate like this one. Okay. ठीक है जी. And now last question is a vector parallel from PQ with magnitude of 10. So vector parallel to PQ means both the direction of the same. PQ in the same direction. In the same direction, you have to take the parallel vector. You have to find the parallel vector, which magnitude is 10. Which magnitude is 10. Let's say we have the vector A that have the direction A, magnitude is A, and the direction is small a, superscript A. Okay, and the direction and the magnitude of this vector should be A equal to 10. It is given. Okay, now we have to draw the vector parallel to PQ. So PQ, you know what is the PQ vector? PQ vector is this one, minus 3, minus 1, plus 1. So this is the RPQ. Okay, so first you have to calculate the direction. So unit vector you can calculate like this one. Okay, and based on this, just multiply by the 10 so that you can associate the same vector in the with magnitude of 10. Okay, so now come to the next problem. That is the discussion. That is the vector problem. So I will give you some assignment. Okay, I will post you on the Google Classroom so that you can solve, to practice just on that problem. Okay, now come to the next. This is the multiplication. Okay, so when two vectors A and B are multiplied, the resultant should be either the scalar or the vector, right? Not necessarily this is either scalar or the vector. If the vector is the vector multiplication can give both either the scalar quantity or the vector quantity. That depends on how they are multiplied. Okay, so the first type of the vector multiplication, the dot product, as you know, A dot B, and the vector, the cross product, that is A cross B. Okay, and third one and fourth one is the triple product. Okay, or you can say three product of ABC. So this is the scalar triple product, and third one is the vector triple product, A dot B cross C, and second with the A cross B cross C, right? So this one is, now come the detail of that dot product. Okay, so the dot product of the two vectors A and B, simply A dot B is equal to nothing but the AB cos theta AB, right? As you know, and so how it is defined geometrically? It is defined geometrically the product of magnitude AB and the cosine of the angle between them, right? This is the cosine angle between them. Okay, if theta is the smaller angle, so होना क्या है? If the theta is equal to, let's say, 0, so cos 0 is equal to 1, right? So it simply gives the AB. If the theta is equal to 90 degree, if the theta is simply 90 degree, it means in the orthogonal or perpendicular, then the product will be 0. The product will be simply 0. And if the theta is in the same direction, both the vectors have the same direction. Okay, that is the theta equal to 0. Then when you multiply, simply we will get this one, right? Okay, so AX BX plus AY BY and plus AZ BZ, right? So you already know what is the vector product dot product will follow the commutative law as well as the distributive law as well as, and this is the basic structure of the when the direction will be same and direction will not be the same. In this second one, you can see here both have the same direction, so the product will be one for the unit vector. Okay, for the unit vector, and if it is in the orthogonal or the perpendicular, then it will be 0. It is very important. Okay, now comes the cross product. The cross product of two vectors a cross b, simply a cross b we can write. So it will give the vector quantity. It will give the vector quantity whose magnitude is the area of parallelopiped. It is very important. Is the area of the parallelopiped found by a vector and the b vector in the direction of advanced right-handed screw. They are as shown in the figure. So let's say this is the a vector and this one is the b vector. Now we are just moving to a to b. Okay, we are curling our hand in the upward direction of the thumb a to b, and this direction will provide, the thumb will provide the direction of the a cross b. Okay, this is the normal. Okay, so simply we can write a cross b is ab sine theta in the direction of perpendicular or orthogonal, right? So where an is the unit vector normal to the plane. So let's say this is the x and y plane. Let's say xy plane, and on this plane this is the xy plane, right? On the plane, on the perpendicular, the unit vector normal to this plane is representing the we are moving like this one. If we are moved like this, then the direction is representing the downward direction. Okay, the direction of an is taken the direction of the right thumb when the fingers of the right hander rotate from a to b as shown in this figure, right? Now C vector is equals to what? C vector is equals to a cross b. How it can be written? So this is the an. An means what? The whatever the we are multiplying with the a and b, right? So ये आपका क्या होगा? This is the a vector, unit vector. This is the b vector. So the direction of this will simply an, right? Simply of an. An nothing. An is the cross product. What is the cross product of this one? A cross b divided by sin theta. Okay. So this will be give the direction. Is it okay? So in the matrix form, the a cross b represented ax, ay, az, the magnitude of ax, ay, az, bx, by, bz. This will provide the a cross b. Okay, and remember it is not follow the commutative law. This is a cross b is not equal to the b cross a. Why? Because of direction. It will represent the upper direction, then it will represent the downward direction. Okay, you can see visualize from this picture. If a cross b means we are going from a to b. Okay, so the direction will be the upward, and if we are b cross, we're talking about the b cross, then the direction is the downward. Okay, so a cross b is not equal to the b cross a. It means this is not follow the commutative. So this is the simple, you can understand. You already studied in the 12th or 11th class. So ax, okay, ay, az, when you multiply with both, you can find out like this: ax into cross ay is equals to az. Ay, आप simply आप क्या करें? This is the ax, ay, and az. Okay, when you multiply with this, you will got this. When you multiply this, you will got this. You will multiply this, you will got this. So by this way, you can calculate ax into ay cross ay is equals to az. Ay cross az equals to ax. Az cross ax is equals to x. We are moving like this one. If we will move like this, then the sign will be changed. Okay, right? It is anti-commutative. Okay, it is anti-commutative. It is not associative. Same principle you can apply here also. The distributive, yes, it is distributive because you're just adding something with this one. So a cross b plus a cross c, you can write. You can write a cross b. You can also validate these things. Okay, a cross a, because why 0? Because the angle between this is 0. That wise, okay, 0. Okay. Now come the triple product. Now given three product a, b, c, we define the scalar triple product. So a dot b cross c. Okay. Also you can write b cross c cross a like this one. A, b, c. So A, B, C, B, C, A, C, A, B, both are the same, all the same, all the same. You can obtain by the cycling permutation. A, B, C, A, B, C, A, B, C, A, B, C. Okay, A cross B cross A dot B cross C, B dot C cross A dot B cross, इस तरह से C dot A cross B you can write. Okay, and if this is A, if the matrix A is represented in the Cartesian plane AX AY AZ, and B is represented in the Cartesian plane BX BY BZ, and C represented the Cartesian plane CY CY CZ, then A dot B cross C, how will you calculate? It is simply, it represents the volume of the parallel pipe. Volume of the parallel pipe. Okay. So it is calculated by the 3 by 3 matrix. You can represent it AX AY AZ, BX BY BZ, and CX CY GZ. You already know. Okay. So this is, there is some problem. I think given the parallel pipe, volume of parallel pipe, we have to find. Okay, this will come. Come to the next vector triple product. This is A cross B cross C, A cross B cross C, and it is equal to the B dot A dot B A dot C and C A dot B. This also you have studied in the previous class. Okay, so A cross B cross C is equal to B A dot C, C A dot B. Is it okay? So it is also B A C C A B, obtained using back cab rule. Okay, back cab rule. So you can remember like this one, right? So this is the simple problem given for your practice. Verify Lagrange identity, which states that if A vector and B vector are two arbitrary vector, then you have to calculate, you have to prove this one also, right? So this is for the practice, just to practice this. You can take the screenshot of this slide and just to try to practice. If you are not able to find, I will help you, right? This is also, you can take the screenshot and just try to practice. A vector, B vector is given. You have to find the angle between them, that is theta. Okay, so try to find out either with the help of the dot product or the cross product. You can use both the techniques. Okay, you can take the screenshot of this course, or you can take the help of a video, streaming video, right? So three field quantities are given: P vector, Q vector, and R vector. You have to find P plus Q, P minus Q, and then take the cross product, right? So you have to, apply the associative law. Q dot R cross P, P dot Q dot cross R, sine theta QR, and P cross Q cross R, a unit vector perpendicular to both Q and R, and the component P along Q. Just to try to practice. If you are not able, then the solution is also given. You can take the screenshot. Okay, all things we have discussed in the example, right? So just take the screenshot and you can solve like this one. Okay, just try. Okay, now come to the next part, that is the coordinate system and the transformation. Coordinate system and transformation. So for this coordinate system, first we have to understand what is the coordinate system. So first one is, I think, the Cartesian rectangular system. There are generally three coordinate system we are using in the coordinate system. First one is the Cartesian, second one is the cylindrical, and third one is the spherical. Okay, and all this, let's say we have discussing about the rectangular Cartesian system. Let's say we have the A vector. So in the Cartesian system, generally more popularly, generally we are using rectangular, so you can say that rectangular Cartesian system. So it is simply represented by the AX, AY, AZ, right? And associated with this, their direction. That is AX, AY, AZ. Okay. AX, small AX, AY, AZ simply represent the vectors. You can say this is the X, this is the Y, this is the Z. So this is the rectangular Cartesian system. Let's say there is a point P. Okay. So the P have certain, point. So अब कैसे find out करेंगे? So AX लेट्स से दिस यहाँ से फाइंड आउट करना है, यहाँ से आप ax की तरफ गए, यहाँ से आप ay की तरफ गए, और यहाँ से आप az की तरफ गए. The both the common plate, the common will give the that point, right? That will give the common point. Okay. So the you can also say the coordinate x is lying from minus infinity, minus minus infinity, है ना, minus infinity to plus infinity to minus infinity. Sorry. And y is also lying from the minus infinity to plus infinity. Z is also minus infinity to plus infinity. So to describe the vector accurately and to express the vector in terms of the component, it is necessary to have some reference direction. Such directions are represented in terms of the various coordinate system. There are number of coordinate system available in mathematics. First system is the Cartesian, second is cylindrical, third is spherical. Right. So first we are discussing the Cartesian or rectangular coordinate system. So this is the origin. The rotation also given. Okay, x to y, y to z, and z to x, like this one. Okay, and the rotation is here also given. This is the x to y, y to z. So अगर आप इस तरीके से करेंगे, that is the the anti-clockwise. Okay, so anti-clockwise represent the upward, and the clockwise represent the left-handed, represent the the downward direction. Okay, so simply this is the representation, nothing else. Okay, so as we have discussed, let's say this is the point P x1 y comma z1. So let's say this is the x1, this is the y1, and this one the z1. The common point that represents the P. Okay, first we have to come to x, then we have to come to the y. Both the projection of this one is z. So this is the representation of P point x1. I'm repeating once again. First come to the x1 point, then go to the y1, take the intersection of both the point, and then projection of both the plane in the upward direction, that is the z. That z3, with the help of three information, you can point it out this point P x1 y1 comma z1. Okay, this is already discussed. Okay, now if there is a x constant, x is a constant, x is constant means yz plane में parallel में जा रहा है, yes or no? If there's a some quantity are constant, it is not varying, it means like going like this one. Sorry, yes. Okay, so y and z are the plane, and x parallel to this plane, you can draw this one. Okay, similarly the xz plane में y constant, if the y is constant, you can draw like that one, and if the z is constant, then what it represents? It represents simply the plane that is parallel to the xy plane, right? Sir, मैं क्लास में मैं अभी करता हूँ ना क्लास में, xy plane, right? Now come to the next, that is a representation of point in a rectangular coordinate system. So we use ax, ay, az to indicate the direction of the component. So how this be? We have already discussed the position, how the position vector can calculated. So this is the magnitude x, y, z, and the direction of this is ax, ay, and az. So you can written like this one. Okay, so what is the x, y, z? The scalar projection that I already discussed here. Okay, first you go to the x, then y, take the projection on the z direction, and whatever the z will tell, all the common point and intersection point will represent the P. Okay. Okay, so let's say we have the two vectors, A vector and the B vector. So A is represented like this and B vector is represented like this. Okay, A is here and B is here. Okay, in the Cartesian system. So now suppose that we have to add both the vectors, A vectors and the B vectors. Okay, so similarly, जैसा हम लोगों ने previously पढ़ा कैसे करना है, so just take the parallelogram, follow the parallelogram rule. Either make the parallel to the A parallel to this in this direction, or you can take also the parallel to B. You can draw like this one, right? And take the parallel, follow the parallel and add them, A vector plus B vector or the B vector plus A vector. Since it is a commutative, you can add two vectors in both the way. Okay. Okay. So C vector represents simply what? Ax plus bx in the direction of ax, ay plus by in the AY direction and AZ plus BZ in the AZ direction. Is it clear? So simple. This one is the addition, and as you know, both are the all these Cartesian coordinate system, rectangular Cartesian coordinate systems are the orthogonal system, since it is a mutually perpendicular to each other. Okay, so the dot product simply AX and AY AZ. Since theta is equals to 0, then cos theta equals to 1, and due to that property we have just taken the 1, okay, the magnitude. And if it is the perpendicular to each other, then it will obviously give the, due to the theta equals to 90 degree, cos 90 becomes 0, and due to that property you can take like this one. Okay, so okay, you can take the cross product also in the same way. AX comma across is 0, because theta is equals to 0, theta is equals to 0 and sine 0 is 0, right? So due to that property, this will become 0. And the AX AY cycling property, as we have discussed. Okay, so AX cross AY will give the AZ, AY cross AZ gives the AX, and AZ cross AX is equals to give the AY. Okay, so let's say A dot B, to ऐसा निकाल लेंगे हम लोग, what is the component, what is the magnitude of the vector A, right? So you can calculate A square, and how the distance will be calculated. Let's the P vector is this one and Q vector is this one, then PQ vector we have to calculate. Okay, so Q vector minus P vector, represent the distance. Okay, and it is represented like this one, and the magnitude is how the magnitude is calculated, x2 minus x1 whole square. It is given also x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square, root over. Okay, and what is the direction of PQ vector? So you can also calculate with the help of the unit vector, right? So based on this, the problem is given, the find the unit vector AC and the angle it makes with the z-axis. Okay, so just I am stopping here, and we will discuss the differential elements in the Cartesian coordinate system, usually in the rectangular coordinate system, in the upcoming lecture, the next lecture. Okay.